You've seen that, right? These absolutely mind-bending images that AI can create. But what if I told you that a massive leap forward in making them even better came from an idea that is, well, just incredibly simple? Today, we're going to break down some fascinating research that shows how sometimes the most elegant solution is also the most powerful one.
Okay, so to really get what's going on here, let's use a little analogy. Imagine every AI image model has two parts inside it: an art critic who knows exactly what a good picture should look like, and an artist whose job is to actually create it. So, what happens if they don't speak the same language? And that right there, that's the core problem researchers have been wrestling with.
Yeah, so this gets us to our first big idea, this concept of an AI having two different minds, or at least two very different processes. One is all about deep, complex understanding, the seeing part, and the other is all about pixel-perfect creation.
Now here's the kicker. For a long time, these two processes have basically been fighting each other. They have totally different needs, and they process information in completely different ways. It's like a traffic jam, a huge bottleneck happening right inside the AI.
And this clash, well, it actually has a name. Researchers call it the generation mismatch, and it's the main villain this new paper decided to take on. It's just the technical way of saying our artist and our critic are not on the same page at all.
Okay, so let's break this down, because this is where it gets really clear. The art critic, or the encoder part, is thinking in this super complex, abstract language. It has to understand all the different ways you could imagine a cat sitting on a mat. But the artist, the generator, it needs a paint-by-numbers kit. Super simple, super precise instructions to actually draw the thing. It has to get every single detail right. You see the problem? These are two completely opposite goals.
You know, trying to fix this has been a total nightmare for developers. The old solutions involved building these ridiculously complex systems, almost like hiring a whole army of translators and therapists to get the critic and the artist to talk to each other. I mean, sure, it kind of worked, but it was just so clunky and expensive, and it took a ton of computing power. And that brings us to the breakthrough, a brand new framework with a radically simpler idea. And its name kind of says it all. One layer is enough. So, the solution is called FAE, which stands for Feature Auto-Encoder. Basically, its whole job is to be that perfect, simple translator we've been talking about, sitting right between the AI's two minds. It's built to adapt all that powerful knowledge from pre-trained models specifically for making images, but without all that messy complexity. So, what's the magic trick here? How does it actually work? Well, a quote straight from the paper gives us the secret sauce. The key, they say, is to couple two separate deep decoders. So instead of one giant, complicated process, they just use two simple, specialized ones. And this shows the whole genius process. Let's walk through it. First, FAE takes that deep understanding from an existing pre-trained model. Then, and this is the key, a single, simple layer adapts it. From there, the first decoder has only one job: translate that idea back into the critic's complex language. Then, the second decoder takes that perfect translation and uses it to generate the final beautiful image for the artist. It's just a clean, brilliant division of labor. Okay, so the idea sounds great on paper, right? It's elegant, it's simple, but the real question is, does it actually, work? Can this simple little idea really go head-to-head with the giant, complex models that are out there? Well, let's look at the results.
So, yeah, how did this clever theory actually hold up when the rubber hit the road? Honestly, the results are pretty shocking. Well, the answer really kicks off with this one number, 1.29. That's the best FID score FAE got on a standard ImageNet test. Now, that number might not mean a whole lot to you by itself, but trust me when I say, in the world of AI image generation, that is a wildly good number. So you're probably asking, what the heck is an FID score? It stands for Frechette Inception Distance, and it's basically the gold standard for measuring how realistic an AI-generated picture is. All you really need to remember is this: lower is better. The lower the number, the more realistic and high quality the picture.
And this chart really drives the point home. That 1.29 score isn't just good, it's right up there with the best of the best, near state-of-the-art. FAE, with its super simple design, is performing at the same level as models that are way more complicated. Simplicity didn't just compete here, it pretty much won. But wait, it gets even better. It turns out this simple approach isn't just super effective, it's also incredibly efficient.
It learns way, way faster. Okay, check this out because this is where my jaw kinda dropped. In one test, the model hit a state-of-the-art score of 1.48 after 800 training cycles. Great, but look at that second row. With only 80 cycles, that's just 10% of the training time, it got a score of 2.08, a score that by itself is better than many fully trained models, and it did it in a tiny fraction of the time. That is just unbelievably fast learning. All right, so let's pull all this together. Why is this such a big deal? Because it points to a whole new philosophy for building AI. It's all about working smarter, not harder. So, what are the big takeaways? What do you need to remember? 1, the FAA framework is simple. We're talking as little as a single layer to fix that communication gap. 2, it's incredibly effective, hitting top-tier image quality. 3, it's super efficient, learning way faster than its rivals. And 4, it's generic. This idea isn't a one-trick pony. You can plug it into all different kinds of AI models, making it a seriously versatile and powerful tool. And that just leaves us with one last thought. This research took on a huge, fundamental conflict inside of AI and fixed it with a solution that was just surprisingly simple. It just makes you wonder, right? What other huge, complicated problems out there are just waiting for someone to come along with that one simple, elegant idea that changes everything?